And remaining, I can make this guy. Okay, hold on. I'll make this guy in the area number 1. So we have a 2 different area now. Okay. So perfect, right? So style and change is the. So I'll go with the yellow is very dark. Let's go with the just now. Okay, perfect, right? And I'll call this guy. Let me text edit, and I'll say this guy should be 28 is fine, right? Okay. So this is the area 0 we have, and this guy go with the area number 1. Right. So all good, right? Hey guys, welcome back everybody. So what we have done, so if you guys remember that we have covered the concept of the DRB here, we have seen that basically what is the difference between the EIGRP and WISP routing protocol. So if you compare with the EIGRP doesn't have any concept of the DR and VDR. That's a beauty part in the OSP protocol. So we have a DR and VDR, and you can make like by default it will go with the higher priority. If the priority get tied, then what happened? The by default it will take the higher route ID. So priority is a by default one. A 0 is a special priority. So if you're going to configure any interface as the priority is a 0, that interface will never participate in the DR and VDR itself, right? Then after that, we have seen that the whatever the network type we have, broadcast, point to multipoint, non-broadcast. So majorly, right, if I talk about nowadays, so you will only see the broadcast and point to point. Somewhere, like a DMVPN scenario, one of the VPN scenario, you will see the point to multipoint, but non-broadcast, you will not see that. The DR
और
VDR,
दूध कितना मंगा लो, आधा लीटर 1 लीटर?
2 liter होगा भाई. So on a point-to-point network, we don't have a DR, and point-to-multipoint, we don't have a DR-BDR concept. You can make any broadcast network into the point-to-point by simple command, right? If you're gonna make a point-to-point, then you will not have a DR and BDR, right? Same way, then after that, we have seen how to configure the OSPF protocol between the two router OSPF one, and simply you can enable this guy. You can make this interface as a part of the area 0, and say another way you can define in the dotted decimal format. Process ID, we have seen that it's a 16-bit of number. It's a locally significant number. So if the router 1 has a process ID 1 and if the router 2 has a process ID 2, still they can form the neighborhood, right? And LSDB table we have, that's going to maintain the LSA information. So I have also shown you the one of the scenario, right, there where you can use the 2 different process ID. Like when you have a customer router, they are running with the OSPF process ID 2, and the service provider router, they are running with the OSPF process ID 1. So in that scenario, you will see the 2 different process ID between this guy to this guy. हाँ बड़ा भाई, जैसे मैं अभी थोड़ा सा बिजी हूँ, लाइक इन क्लास में हूँ. आप मुझे कंफर्म कर दो ना, क्योंकि पुनीत वाज आस्किंग, अदरवाइज पुनीत का मुझे कहीं और वो बोल रहा था. हाँ बोलो बोलो बोलो. हाँ that's fine, we can give the recording, that's fine, anyways that's fine. नहीं नहीं नहीं, that's fine, we can give the recording. So तो आप, हाँ वो थोड़ा फोन कम उठाता है. मेरे टाइम में CCI. So after that, we have seen that whatever the neighborhood criteria we have, guys, and then after that, we have seen the concept of all the packets in the OSPF. So each packet has a different use case, right? Remember one thing, all these packets are encapsulated by the IP header, and every packet has a same OSPF header. Every packet has a same OSPF header. Then after that, we have also seen the concept of the most important thing, the concept of the LSA. LSA is called as the link state advertisement, right? The full form of the LSA. So basically, it's setting the link information, which is known as the LSA. LSA is stored in the LSDB table called as the link state database table. It's a collection of LSAs we have. Depend on the areas, you will have a LSA. So if you have a single area, in the single area, you will only have a LSA number 1 and LSA number 2, which is known as the network LSA. And you have a 2 types of network. Either one will be the stop network like a loopback, and a transit network like a interface, right? So for example, we have router number 1 and we have router number 2 over there. And this is the interface 0/0 we have. This is the loopback we have 1 So this loopback is known as a stop network, and this interface is known as a transit network, right? Then after that, I told you that if you remember, so within the area, the ospf maintain the detailed information. So it will have identical information between the area, right? It doesn't have a identical information. It has a summary information. That's why it's called as a distance vector routing protocol. And because of the like all you have a detailed information, ospf is a recommendation to deploy in the service provider network. Either you can do the ospf and iss protocol. Then after that, we have seen the concept of the LSDB table. In the LSDB table, we have seen that router LSA. So the link ID, the most important thing, the link ID of the router LSA will be the router ID I have mentioned over there. And advertising data also will be the router ID, right? And same thing in the network LSA, what happened? The link ID will be the DR IP address, and advertising data will be the router ID of there. So we have seen these two LSA, and this two LSA only comes in the picture within the area. So let me give you the one scenario over there. Take example, we have router number 1, we have router number 2, and we have router 3 over there. So this is the, understand, this is the, we have a 10.1.12.0/24 subnet, and then we have a 12.1, and this guy is a 12.2 we have. This is a 23.2, and this is a 23.3. Can you tell me, first tell me one thing, who will be the DR in this picture right now? Who will be the DR in this picture? Yeah, can you hear me, guys? Who will be the DR in this picture? Anyone? No? Great. So the DR will be, this interface will be the DR, and this interface will be the DR. And of course, you will have a 3 router LSA, right? And if you talk about the network LSA, you have a 2 network LSA. So the router LSA, router 1 will generate the own router LSA, router 2 will generate the own router LSA, router 3 will generate the own router LSA. If I talk about the network LSA, router 12.2 will generate the network LSA, and 23.3 will generate the network LSA. Right? Perfect. R2 will be the DR. No, of course, the R2 interface will be the DR, and R3 interface will be the DR. Now, the third type of LSA that we have. So before I'm going to introduce the third types of LSA, guys, please pay attention. You have a single area concept, right? So in a single area, you have seen that either you can make a area 0, either you can make a area number 1, either you can make a area number 2, anything, right? Any you get. So for example, we have a router over there, router number 1, and the same way we have a router number 2 as well. So I can make this guy understand the concept, I can make this router 1 and router 2 as a part of the one area, right? So either I can make this guy as a area number 0, either I can make this guy as a area number 1, or either I can make the area number 2. It's totally up to you. So within the single area, we don't have any issue, right? But why the multi-area concept comes in the picture? What's the reason behind it? The multi-area. So the reason behind it, right, in a simple language, if I tell you, right, if you go with the higher level, so we have a different things. Like we have almost 2 hours of the discussion only on the multi-area concept. So I'm just giving the simple behavior, why the multi-area comes in the picture, simply to just reduce the load on the router. Simply to reduce the load on the router side. For example, if I say the router number 1 we have, and router number 2 we have, and router 3 we have, and router 4 also we have, understand the concept. If I'm going to make all this guy as a part of the area number 1, understand this concept, then what happened? All the router has to maintain the detailed information about all the router. So router 1 has to maintain the detailed information of the router number 2, router 3, and router 4. Router number 2 has to maintain the detailed information of the router number 1, router 3, and router 4. Router 3 has to maintain the detailed information of the router 2, router 1, and router 4. Router 4 has to maintain the detailed information of the router 3, router 2, and router 1. So every router has to maintain the detailed information, right? So in that case, what happened? The load will be there, right? CPU will be high, memory consumption will be high. In that case, what happened? The performance will be degraded. What I told you that router is not only to run the routing protocol. Router is not only to run the routing protocol, because on the router side, you are also going to do the NAT. On the router side, you are also going to do the ACL. On the router side, you are also going to do the HSRP protocol. On the router side, you are also going to do the quality of service as well. Maybe on the router side, you're also going to do the multicasting. Maybe on the router, you're also going to do the VPN. So if I'm going to put all the resources, understand the concept, guys. If I'm going to put all the resources only for the routing protocol, Doesn't matter OSPF and area GRP. If I'm gonna put all the process, right, all the CPU and memory only for the routing protocol, then what happened? Can I use this process? Can I use this features on the router? You can run, but some of the features cannot be run. The reason is that if the router doesn't have enough memory, you cannot do the NAT and VPN. So that's why, to reduce the overheat on the router side, what I can do that, I'll divide this guy into the area. I'll say that router 1 and router 2 will be the one area, and from the router 2 to this guy will be the part of the different area. So I'll make this guy the area number 1, I'll make this guy the area number 0. So in that case, what happened? Now, previously, each router has to maintain the detailed information. Now what happened? Router 1 is only going to maintain the detailed information of the router number 2. Router number 2 is only going to maintain the detailed information of the router number 1 for this area. Again, now the router 2 is going to maintain the detailed information of the router 2 and router 4. Router 3 is only going to maintain the detailed information of the router number 2 and router 4. Router 4 is only going to maintain the detailed information of the router 2, router 3, and router 4. Right? So this beauty you have with the help of multi-area concept. In a multi-area concept, what happened? Now each router is not going to maintain the detailed information. Only the within the area, in an area 0, only the router 1 is going to maintain the detailed information of the router number 2. In the area number 1, on the router number 4 only going to maintain the detailed information of the router 2 and router 3. Router 4 is not going to maintain the detailed information of the router number 1. So I can save the resources on a router 4 and router 1 as well. That's how the multi-area concept comes in the picture, right? So multi-area, you can do that. You can take any area. We have a 32-bit range of area. You can pick any area in the 32-bit range, but make sure that area 0 is represented as a backbone area. Always remember. So area backbone means what? A person has a backbone, right? Every people has a backbone. If your backbone is not going to work, can you run? Can you like walk on the? Can you walk? Can you run? You cannot do that. Even you cannot do any work if you don't have a backbone. Same thing. Area 0 must be present in your OSPF domain. If you have a multi-area concept, area 0 must be present. Area 0 must be present in OSPF if you have a multi-area concept. If you don't have a area 0, then you cannot provide the inter-area communication. If you don't have a area 0, if you don't have area 0, then you cannot provide inter-area communication. So it must be there. It's mandatory part. So for example, understand the concept now. Now understand the concept now. So what I say that if you don't have a area 0, then you cannot provide the inter-area communication, right? So take example, we have router number 1, and we have router number 2 over there, and we have router 3 over there. So in this case, what happened? Understand. So there is a loop back behind this guy, 1.1.1.1. There's a loop back behind the R3, that's 3.3.3.3.3. I'll make this guy as this interface and this interface 0/0 and 0/0, 0/1 and 0/0 as well. So I'll make this two interface as a part of what? So this guy from here to here, it's a part of the right now area 0. Sorry, area 1. Understand? And from here to here, what I can do that? I'll make this guy the part of the area number 2 right now. So in that case, do we have area 0 over there? I don't have area 0. So in that case, the user sitting behind the 1.1.1, the user sitting behind the 3.3.3, they cannot communicate to each other because we don't have a area 0. Area 0 must be present. If you don't have a area 0, you cannot achieve the inter-area communication. Same way, what happens? Same topology pattern one we had. I said router number 1 we have, router 2 we have, and router 3 we have. And router 3 has a loopback 3.3.3.3.3.3, and router 1 has a loop back is a 1.1.1.1.1, and there's a area number 1 and area number 0 we have. In that case, what happened? From here to here, I'm going to make this guy the part of the area number 1. And from here to here, I'm going to make this part of the area number 0. In that case, what happened? So when the area 0 comes in the picture, right, eventually what happened, this router is behaved like a border router, known as a area border router, ABR. So area border router comes in the picture when your router has a connectivity with the area 0. So one interface of this router as a part of the area number 1, another interface is a part of the area number 0. So eventually what happened, if the one router, right, if the one router has a multiple interface and one of the interface is a part of the area 0, any one of the per interface, doesn't matter the physical or loopback. So take example, even in this case, try to understand, right now area 1 and area 2 is there, right? So we cannot achieve the communication between this PC to this PC. But what happened if I'm going to create the one loop back over there, that's a 2.2.2.2.2. And if I'm going to not convert, if I'm going to enable this interface into the area 0, then what happened? Now this interface, this router will become an ABR. Once this router will become the ABR, now you can have a communication between this guy to this guy. So it doesn't matter that either you have a physical interface is part of the area 0, or either you have a logical interface is the part of area 0. If the router will become the ABR, then you have an inter-area communication. But if you're not going to enable this area 0 over there, this loopback, then there will be no ABR now. And if there is no ABR, then what happened? You won't have a communication between this guy to this guy. So area 0 must be present because of the area 0, what happened? You will have an ABR. So there is a condition of the ABR is what? At least one interface should be a part of the area 0. So this router 2, this interface is the part of the area number 1, and this interface is a part of the area number 0. So eventually router 2 will become the ABR router. Right? So in that case, understand the concept now. Understand the concept. How many routers we have? 3 routers. Understand the concept. How many routers we have? 3 routers. Right? So router 1 will generate the own router LSA. Router 2 will generate the one router LSA for the area number 1. And router 2 will generate the another router LSA for the area number 0. So now in this picture, total you have a 4 router LSA. How? Router 2 will generate the one router LSA for the area number 1, and router 2 will generate the one router LSA for the area number 0. So one router LSA, 2 router LSA, and 3 router LSA, 4 router LSA. So total you will have a 4 router LSA in this picture. These are the very, very important questions for the interview right now, guys. Please pay attention and understand the concept. For each area, you will have a separate router LSA. Right? Now let's have a look. So if you see the same topology, I just converted into the different area 0 and area number 1 we have, right? What I can do that, let me do it this way. What I can do that, let me fire off all those devices, and I can reduce the size so that I can have my, so in this picture, right, you can see that. So router 5 will behave like a ABR router. What happened? One minute. Let me restart my GNS again. Back. Right. Let me restart the GNS. So router LSA and network LSA is only part of the area, own area. It will never travel between the areas. Remember, the one condition is only have the AVR is what? There is a condition to become a AVR, right? Area border router. Condition is what? At least one interface should be part of area 0, right? At least one interface. So for example, the router number 1, interface 0/0 is a part of the ospf number area 1, area 0. Another interface should be the part of the area number 1. Then what happened? Then this router 1 will become the AVR router, because one interface is the part of the area 0, another interface is the part of the area number 1. So this router is called the AVR router. Right? Now let's have a look. Let me remove this guy. I don't need it. Okay. The third type of LSC that we have right now, let me, oh man, my diagram is a little weird. Okay. And hold on. 78.8, 57.7, and 57.5. And right. All good, right? So let me take a console. At least one of the node will be started, right? I haven't started. So already the IP address is configured, guys. I just need to configure the OSPF, right? So as I told you that we have two ways to configure the OSPF, right? One way is you just need to go on the route of OSPF 1 and say the network kind of 1.12.0/24 and area 0, you can make it. Another way we have just need to go under the interface IP OSPF 1 area 0. That's all. Two ways we have. So I'll go with the this ways, right? That will be fine. Or what I can do that. Yeah, I'll go with it this way because already every router has a loop back. So that will be fine. So let me take a console. Taking a little bit of time, man. Meantime, I'll just write on the third LSA type we have. That's called as a summary LSA. It's known as the type 3 LSA, right? Also called as a LSA 3. Basically, this LSA is generated by the ABR order. ABR order. It contains the network ID information. or we can simply say that it contains the router information in a normal language, right? So only the AVR will generate this LSA3, and that has the information about the network ID. All good. So if you have a look right now, how many routers have router 5, router 1, router 5, router 1, router 6 is missing, router 7 is missing, router 8 is missing. Router 1, router 2, router 3, router 4, router 6, and 7, 8. Looks like there is some issues in my GNS3 now. And so I'm getting the console of this. What happened is GNS3. Wait, let me check my having enough space. Now the router 6 is coming back. Let me do this lab 1Y PM. I'll just need a few minutes to create the lab. Okay. Looks like everything's slow in my laptop today. I'm pausing the recording meantime, guys. So of course, my data file will be part of the two interface, right? So this interface is a part of the area 0, right? And this interface is a part of the area number 1. So obviously this router will become the AVR router. So this AVR router will have a complete information of this area 0 and area number 1. He's the router, the AVR router is gonna generate the summary LSA. So whatever the area 0 LSA will be there, all this LSA will be converted into the summary LSA. R5 will generate the summary LSA to this guy. And for all this area number ones, right, he will generate the summary LSA to the area number 0. So area number 1, right, have all detailed information. When it comes to the router 5, router 5 will convert the all the detailed information, the sorted information, and it will to the area 0. Same thing, area 0 has a detailed information. When it comes to router number 5, what router 5 will do that? It will convert this detailed information into the sort information, and it will attach to the area number 1. So AVR is the router who's going to do all those things. So normally what happens in that case, understand the concept. So in this area 0, if you see router 1, router 2, router 3, router 4, router 5, router 6, we have, right? All this router, right? All this router will have a what? Have a router LSA, right? So total we have a 6 router LSA in this case, right? And if I talk about the network LSA, you will have a 1 network LSA, right? So total we have a 7 LSAs we have. So when the router 5, these 7 LSA, we can call the detailed information, right? It's called the detailed information. When the router 5 is gonna advertise the summary LSA about the area 0, it will advertise the only one summary LSA. Because what I told you that in the summary LSA contains the network information. So router 5 is only going to advertise the this network 192.168.1.0/24. So in a summary LSA, you will only have a network information. Same thing, understand the concept. So in the router 5, router 6, router 5, router 7, router 8, in the area number 1, you will have 3 router LSA and 2 network LSA. So totally you have a 5 LSA now. So when the router 5 is going to advertise, right, the area in 1 information, when the router 5 is going to advertise area 1 information into the area number 0, it will only advertise the 2 summary LSA. How? One this guy and another this guy. Is there any limit of the router for the single area? Yes, Boozer. So there is a limit of the routers in a single area. That's a limit is you can put the 50 to 60 routers over there. But again, this is a just written words on the Cisco documents, but it is not depend on the number of routers. It's totally depend on the how many LSAs you have, right? So many times in the interview people are asking this question, okay, how many routers we can put in the single area, and people are saying the 50 to 60 routers. It's a wrong statement. It's not a correct statement. The reason it's not a correct statement, see, why it's not a correct statement? Because see, 50 to 60 router, okay, fine. Take example, this 50 to 60 router, understand the concept, okay? If this 50 to 60 router is going to consume almost 100 LSA, understood this concept, right? What happened, right? My 20 routers only is going to contain the 300 LSAs. Understand, the 50 to 60 routers is going to contain the 100 LSA, but what happened in my some other area, only the 20 routers contain the 300 LSA. So can I put this into a single area, the 20 routers? No, because my area doesn't allow the 300 LSA to store it because they don't have enough memory. So I need to reduce this guy into the 1010 or maybe the 55 over there. So yeah, if you want to say someone like how many routers we can have in the single area, you can just say that 50 to 60 routers. But just for your knowledge, it's not a correct statement over there. Yeah, it's written in the documents, but when you go for the CCD level, right? Normally it's a big it will go in the 1 hour of the class if I'm going to explain you how this thing is going to working. But yeah, when you go in the CCD level, then you will understand this concept. But yeah, at the NP level or even the CCI enterprise level, I level, that's fine. This enough information is like how many 50 to 60 how you can put it. But again, just for your knowledge, it's not depend on this statement. It's depend on the how many LSAs you have, what is the router performance, what is the router capacity they have, router CPU and router memory as well. So why not softening, man? It's a little crazy today is happening. I don't know, man. I really have no idea. It's been 15 minutes. It's still coming up. Okay, looks like everyone is now up. So I let me remove the duplicate one. So I can remove the other one I already have. And I can remove the router 6 already have, router 7 already have. Router 3 I have somewhere. I don't have it. Router 2 already have, I have it. Okay, router 4 I already have it somewhere. Yep. Router 3 also I have it somewhere. Yep. So router 1, router 3, router 7, router 5, router 8, router 2, router 4, router 1 again. I just need to remove this guy. Router 6, I need it. Router 8, I need to remove it. Right? And router 5 also. So we have router 1, router 2, router 3, router 4, router 5, router 6, router 7, router 8. Perfect. So on the router number 1, if you see right now, I'm just going to enable the interface label. So I already have all the interfaces configured, right? If you see that. So IP interface brief, same information, it's given over there. I'm just going to enable the interface 0/0 IP host of area 0. On the router number 2 as well, interface 0/0 IP host of 1 area 0. On R3 as well, interface 0/0 IP host of 1 area 0. R4 as well, interface 0/0 IP host of 1 area 0. R5 as well, interface 0/0 IP host of 1 area 0. Router 6 as well, interface 0/0 IP host of 1 area 0. Router 7 as well. Router 6 we have done, right? Router 5 we have done. Router 5 on this particular interface 1/0 IP host of 1 area number 1. Router 6 as well. Not router 6, router 7 as well. Router 7 interface 0/0 IP host of 1 area 1 and interface 1/0. And router 8 now the finally. On the router 8 interface 0/0 IP host of 1 area now. So eventually, if you see, right, what happened, I have same issue of the duplicate routers when CPU is busy to open them. Yeah, man. So you can check on the router number 1, right? Router number 1 is going to form the neighborhood with router 6 and router 5 because router 6 will be the DR router. And if you see one thing, we have already seen the concept of the router and network LSA. If you go to the router 5 right now, so you can see that so IP ospf. If you put the command so IP protocol event, right, you can see that, you know, this is the OSF process one is running. I don't have any filtering over there. That's why it's saying not set, right? The router ID of the router 5 is a 5.5.5 and it's a AVR router. So router 5 is behaved like a AVR router. So if you have a look on the router number 8 on this router, what you can see that so IP OSF database. So you will have a 3 router LSA, of course, router 5, router 7, router 8. You will have a 2 network LSA, 3 router LSA we have, 2 network LSA we have, and you will only have a 1 summary LSA, and that will be advertised by the R5. And this summary LSA is going to contain the information of what the link ID will be this one. So let me put this thing in my paint and I'll put it in the same way. So if you go a bit over here right now, and I'll remove this guy and put it this guy. So if you see here, the link ID was what? The link ID was a DR IP address in the network LSA. Here the link ID is what? It's a network ID. And advertising data will be AVR and remaining all the same information. So you will have only one summary LSA in the area number 1. That is 1.0, which is advertised by the router 5. And router 5 is the AVR router. Same thing if you have a look on the any of the router on the area 0, on the router 1 even up, if you see that. So IP OSPF database. So you will have a 6 router LSA, 1 network LSA, and 2 summary LSA. How 2 summary LSA? R5 is going to advertise the one network, one summary LSA for this network, and one summary LSA for this network. So 6 router LSA, of course, one network LSA, which is the DR R6, and the two summary LSA, which is advertised by the router 5, 5778. All good. Anyone has a question, guys, in the summary LSA? No. So I'm taking as silent as a no. So take example, what happened if I'm going to advertise this loop back on the router number 1? So if I'm going to advertise this loop back on the router number 1, it will behave like a separate network, or we can call it a separate prefix over there, right? So in that case, what happened? You will have another one summary LSA on the router number 8. So in that case, what happened? Router 5 will generate the two summary LSA. One summary LSA will generate the 192.168.1.0, right? Which is this guy, this subnet. And another summary LSA will generate is a 1.0.0/8. The reason, because it is also considered as a separate network over there. So if you go on the router number 1 and advertise the loopback interface, loopback number 1, IP ospf number 1, area 0. If you see on the router 8, now you will have a which command defined on the router 5 ABR. Nothing. I just make this interface as a part of the 0, area 0, and this interface is the part of the area number. Automatically, this router 5 will become the ABR router. So if you see on the router 5, I just enable this interface as the area 0, and this interface is the area number 1. That's all. So now I just advertise this loop back on the router number 1. Now what happened? Router 5 is going to generate another summary LSA. So on the router 8, if you see, you have another one. So summary LSA, simple language, how many networks you have. So if you have a 10 networks, understand the concept. If you have a 10 networks in the area number 1, if you have a 10 networks in the area number 1, or we can say the 10 route, simple language, then router 5 is going to advertise the 10 summary LSA. If the area 0 has a 30 network, or we can call it the 30 routes, then R5 is going to advertise the 30 summary LSA to the area number 1. All good? So now one lab I want to show you. So if you see right now, on the router 8, if you see that, I can send the traffic to the 1.1.1, right? I can send from R8 router, I can send the traffic to the 1.1.1, right? So if you put the command show IP root ospf, you can see that, right? So you can see that the O route is going to represent 57.0. So R8 is saying that, hey, I have a 57.0 network on the router 8 routing table, which is considered as the O route. O route means what? It's called as a intra area route. Intra area means what? Same area route, we can call it, right? Another type of route we have, you can say the OIA route. OIA means what? Inter area route. Inter area means what? The route that is coming from the different area. The route that is coming from. So if you see that this network and this network is coming from the different area on the route 8, it's coming by the area number 0 to the area number 1. So that's called as a OIA route. And for this guy, we have a AD is a 1110. That's a default AD for the OSPF routers. All good. So we have a two types of route, O and OIA. OIA comes in the picture when you get the route from the different area. O comes in the picture when you have a same area route. So on the router 3, if you check on the router 3 routing table, what happened? The 57 and 78.0, this two network will become the OIA route on the router 3, right? But the 1.1.1 will consider as a O route. O route on the router 3, and these are the network is considered as a OIA route. All good. So that's how. So if you're going to ping from the router 8, so if I'm going to send the traffic from the router 8 to the this loop back, I can send it. I don't have any issue because we have a area 0. So if you have a area 0, you have a inter area communication. But take example what happened. Let me stop this guy. And I'll create the one lab. Let me check. I do have a lab on my ABR. Yeah, I have. So I understand this lab right now. So we have a right? So we have a, I can call this guys area number 1 and I can call this guys area number 2. Understand the concept? We just have a area number 2 and area number 1. So we don't have a area 0 over there. So this is the 12.1 and 12.2, and this is the 23 dot. Let me remove this guy. Right? So we have a 12.1 and 12.2, and we have a 23.2 and 23.3. So see over there right now what's happening. We don't have an area 0 over there. So if you don't have area 0, can I provide the communication between this loop back to this loop back? Of course, you cannot do that, right? Because we don't have area 0. So if you don't have area 0, right, you cannot provide the inter-area communication. Very interesting lab, right? Do it in your home as well. Right, and here we go. And now looks like it's working fine, man. So in Rado 1, if you see that. So I'll remove the OSP, whatever the OSP configuration they have on the Rado number 1. So I'll say the no Rado OSP number 1. Let me remove it, whatever the OSP we have. I'll do the everything from the scratch. I also have the OSP 1. Okay, perfect. All done. So without area 0, it looks we have a firewall exam. Uh, you cannot say the firewall. The reason is that, because in the firewall, you can, I mean, say like a good logic, but the logic is not correct because in the firewall, you can allow the certain traffic, right? Based on the policy, but we cannot allow the traffic. We don't have a policy in the OSPF. So Rados performed, I'll just configure in the notepad so that you can also follow this lab through the notepad. So Rado 1, I'll say the Rado OSPF number 1, right? As the router ID will be manually, I'll configure the 1.1.1 network. I'll say the 1.1.12.0 and area 0, right? Of course, IP will be same, guys. So if you see on the do so IP interface brief, the router IP will be 12.1 and 1.1. On the router number 2, at the same time, I'll say the router OS number 1. And router ID will be, make sure that router ID must be unique in the OSF protocol. This is a very important question. They will ask you, hey, tell me if you have a router ID same in the EHRP protocol, can they form the neighborship? People are saying, no, they cannot form the neighborship. In a EHRP, they can form the neighborship, right? But in the OSPF, they can't do that because OSPF, in a OSPF protocol, what happened? The router ID is the neighborship criteria. But in a EHRP protocol, the router ID is not a neighborship criteria. Yeah, you will have issues in EHRP if you have a similar router ID because router ID is used to prevent the loop in a EHRP protocol. You will see in the CCI. Router OSPF now again. 3.3.3.3 network 191.23.0 and here we go. I'll also do one thing, guys. Okay, I'm so sorry, my bad. It should be the area number 1. It should be area number, I think I'm wrong, right? It's area 2, sorry. So it's area number 2. It's area number 2. it's go with the area number 1, that's 23.3, and it's also going the area number. One more thing, if you see, I have a look back. Area number 1, sorry, area number 2, and also on R3, I have a look back. Area number 1. So I'll just copy this configuration on the router number 1. All done. So in that case, router 2 cannot become the AVR router. Never. If you check the router 2 IP address configuration right now, you can see that we have a 12.2 and 23.2. I don't have a the 2.2.2 this one. So I just configure the router ID manually. So as I mentioned, that router ID is just a name of the router. It's not mandatory to have a same IP address on the router. So now you can see that in that case, what happened, router 2 is gonna form the neighborship with the router number 1. Router 2 also gonna form the neighborship with the router number 3. You will have a 2 neighborship, but the most important concept, this route that we have on the router number 1, and this route we have on the router number 3. We don't have this loop back. Let me write on this thing. We don't have this loop back. Right? We just have a loop back on the router number 1 and router 3 right now. And this is the area number 1, area number 2. So in that case, what happened? Router 2 is going to form the neighborship. Router 2 has formed the neighborship with the router number 1, and router 2 also has formed the neighborship with router 3 as well. But the most important thing is what? R2 is not a AVR router, because this interface is the part of the area number 2. This interface is the part of the area number 1. If you see the command, do show IP ospf interface brief. This interface is the area number 1. This interface is the area number 2. So am I behave like an AVR? No, man. If you see the do show IP protocol, I'm not an AVR router. Normally the AVR comes over there, right? It will return over there, AVR. So in the do show IP protocol, I don't see the AVR. So can I provide the communication between this guy to this guy? No. On a router number 2, you will have all the route, right? ospf. Router number 2 has a 1.1, and router number 3 has a 3.3 as well. But router 3 will not have a route from the router 1. Can you see that? Do we have any route? No. Even if you check the router number 1, it doesn't have any route from the router 3. So router 2, like as the guys say that, like it's behave like a firewall, but it's not a firewall. So the route is coming in the 1.0.0 over here. Router 3 also sending the route to this guy, right? And but router number 2 is not sharing the information from one area to another area. The reason is that we don't have an area 0. So if you don't have an area 0, you cannot achieve the inter-area communication. So if you want to achieve the inter-area communication in this topology, what you can do that, just create the one loop back on the router number 2. I'll say the 2.2.2.2.2. And simply I can enable this guy in the host protocol. That's all. But make sure that this loop back should be part of the area 0. So simply what I did, I'll make the 2.2.2.2. I'll configure this guy as the area 0. So this interface is a part of the area number 2. This interface is a part of the area number 1. But I create the one logical interface that's a part of the area number 0. And now what happened? If you see do show IP protocol again, it's behaved like ABR. Previously, it was not a ABR. Now it's behaved like a, yes, you can ping. So now if you can go on router number 1, and previously the router was not there, we have it. So OIA route, because this route is coming from the different area, we have it. I can ping it. I can ping 3.3.3.3, or I can use the source loopback number of it. So this is all about the LSA 3, guys, and AVR concept. So on a router number 1, how many LSA 3 you can see that? On the router number 1, you will see the how many LSA 3? Can anyone tell me? You will have a 3 LSA, right? LSA 3 information. So IP OSPF database. One is 3.3.3 because LSA3 contain the network information. One is 3.3.3, one is a 23.0, and another is a 2.2.2. And who is advertising this guy? 2.2.2. The 2.2 is the ABR router. Same thing on the router 3. If you see how many summary LSA you have, LSA3, again 3. One is 10101, which is this guy. Another is 12.0. And of course, the 2.2.2.2. So that's all about the summary LSA. So anyone has any questions in this topology? I'm telling you, it's very, very important. Recently, one of my students encountered these questions in Juniper one. So yeah, that's very important. So they will ask you, right? Okay. So they will ask you this scenario, area 2, area 1, and they will ask you, hey, one thing problem is that this router is not able to become the ABR. And so if the router is not ABR, it cannot send the traffic from here to here. What should I do? And he will also tell you the condition they will give you. You are not allowed to change the area, right? You are not allowed to change the area. Area is area 2 and area 1. So simply, you can just get the loop back over there and add the area because loop back is a logical interface. I don't need any hardware over there. Guys, anyone has a questions? If you don't have a question, then I have a question, guys. The question that I have right now, are you guys understanding the OSPF? Or like, do you face the difficulties? Because if you're not going to watch the video, if you're not going to do the practice, you will never ever understand the OSPF protocol. Okay, that's my personal suggestion to everybody. So if you're not gonna watch the video, if you're not gonna do the practical, so we have done with the LSA3. Tomorrow I'll cover the LSA4, LSA5, and LSA7. So till Thursday, all the LSA will be done. And maybe on the Friday or maybe on the Saturday, we'll do the class maybe on Saturday for the 1 hour. So maybe on the Friday, we'll be done with the OSP on Saturday. Then BGP comes in the picture again. So if you're not watching the video, if you're not doing the practice, then you will lose a. Is it possible that you can provide the sample lab for the OSPF, just 1 or 2? You already have a lab, man. We did the lab. If you just follow my lab, that's enough one. Okay, I just did the one lab over there. If you remember, we did the one lab in the Monday, last Monday as well, on the Cisco packet tracer. We did this lab as well, right? If you just follow this lab, evenly this follow lab, because if I'm going to give the lab to you, you will never be able to do that. Frankly, I'm telling you right now. Okay, if you're able to finish this lab, first finish this lab, Pradeep, then you can go with the another one. Is BGP harder than OSPF? OSPF is a very simple protocol. If you take a harder, then BGP will become the more harder.